Severe weather season is starting to wind down, so I wanted to talk a little bit about supercells in complexes of thunderstorms, just the different types of storm modes that we experience throughout the severe weather season in the Midwest, in the plains, as knowing the exact storm mode will be easier for you to know if there will be a greater chance of tornadoes or a greater threat of damaging winds or hail. Only that, and the time of the year as well, you can see supercells more early on, and when them complexes of thunderstorms later on. But we're going to dig into the details of supercells, types of supercells, and the types of complexes of thunderstorms as well. A low precipitation supercell, also known as an LP supercell, will carry little precipitation actually. You won't really have as much of a rain shaft in place. The actual structure of the supercell will be a lot more visible. And on radar, assuming there is a lot of rotation, there will be a well-defined hook echo on reflectivity as well. And then this type of supercell is most common in the Midwest and plain states. I would say more of the plain states typically have more of this drier supercells rather than further east into the Midwest, like the Dakotas, Nebraska, Kansas, Oklahoma, Texas always has these low precipitation supercells, but you always can get them in Minnesota, Iowa, Illinois, Wisconsin, even them states. But definitely further west you go into the drier plain states, that's where you most likely have these types of supercells. Now, a classic supercell, which are most favorable in the plains and Midwest as well. The Midwest has more frequent classic supercells than the low precipitation supercells, but most of the rain will be on the northwest side of the supercell or the eastern side as well. It's usually a pretty large hail core or rain core that will be in place, but the most likely area for the most damaging wind will likely be more on the southwest, northwest side of the supercell. Not, it's more towards, it depends if there's rotation and all that stuff with it, like including a mesocyclone. Mesocyclones are most common in supercells, but they develop from a lot of wind shear, but also a lot of different components of several ingredients. But of the basics, you need quite a bit of wind shear aloft and in the low levels of the atmosphere to get the supercells to be organized and move east southeast motions. Again, they can bring damaging hail. Hail could be baseball, softball size in supercells. A greater chance to get big hail on these rather than complexes of thunderstorms. Now, taking a look at the high precipitation supercell, there will be a ton of rain in the supercell, and even if there's rotation or tornado, the radar may not identify a hook echo or more of a hook, like fishing hook on radar, because it's so well wrapped in rain. But you can still identify a tornado in multiple ways from radar even then. But again, if a tornado forms, there will be rain wrapped tornadoes, which are more likely to happen than not rain wrapped tornadoes in the Midwest, it seems, anymore. These typically form along a cold front with a line of storms, like maybe just ahead of a line of storms, but they typically form near a cold front. So they can develop along an outflow boundary, warm front, or any of them. But if they're high precipitation, they typically are close to other storms as well. A MCS, Mesoscale convective system, are the most frequent systems or complexes of thunderstorms that we get in the Midwest each year. We've already had about 8, 9 of them this year, and we'll likely have more this month. They are a collection of storms that acts as a system, so more of a solid line of storms, or it could be even a broken line of storms, but it's usually a pretty long line of storms that can cover maybe up to half a state wide or so, even statewide, and they can also last for over 12 hours at severe strength. These typically are what you get out of derechos. A derecho is pretty much an MCS. It's just derecho criteria is different. An MCS is a much easier criteria, just a complex of thunderstorms that does not have to be severe. A derecho, you do need to have a severe complex for 400 miles or greater. Now, a MCC, a mesoscale convective complex, this is a long-lived cluster of thunderstorms. Typically, they can cover an entire state, but they can also be more of a smaller cluster, more a smaller intense cluster of thunderstorms as well, maybe only about 50 to 100 miles wide or so. So they can be a smaller cluster of a complex. and they usually emerge out of other storm types during the overnight and morning hours. These things would thrive into well over the overnight hours because the small, compact cores of the thunderstorms leads to a more of an easier, dominating outflow dominating complex that will push east southeast pretty rapidly. And MCV, Mesoscale convective vortex, this is a low pressure that brings winds into a circular motion. And MCV will have more of a meso low, just a smaller surface low that will be behind the line of thunderstorms, and that is what can bring pretty strong winds behind the line of storms. Which you just had like a few days ago in Iowa, there was wind gusts up to 45 mile an hour behind a line of thunderstorms. These usually occur. These usually happen after an MCS has dissipated, and it can take up to 12 hours or more for an MCV to also dissipate. Like multiple times this year, an MCV can fuel the next severe weather outbreak. There were a few times this year already, and MCV has allowed several tornadoes to happen in Illinois and into southern Wisconsin as well. Just a few weeks ago, an MCV dropped like 8 tornadoes in Illinois in afternoon and evening time frame. So an MCV usually has enough wind shear, it has enough gradients in place to get a more of a smaller corridor of significant severe weather, including tornadoes in the afternoon and evening hours. Before I wrap up this video, I do want to talk about CAP again, as CAP is used a lot. It has been used this year a lot, and it will be in the future years as well. CAP is an area of warm air aloft in the mid levels of the atmosphere that will prevent storms from developing, or if they do develop, it prevents them from getting severe. Most of the time, storms don't develop because of a CAP being in place. You can look at a CAP being in place from forecast soundings. Usually, you can tell if there's a warm nose about a kilometer or two up on the forecast sounding, and that means there's a cap in place, a lid on the atmosphere that will suppress storm development from happening. But the cap usually breaks at the sunset, or you can have a few different things that can break the cap as well, including like a cold front that might sweep through that can break a cap with enough forcing locally along the cold front to get storms to initiate and maybe strengthen as well. Or you can also get a arrival of a shortwave trough, just enough forcing and to push in to erode this cap.